accelerated expansion that we think happened in the early universe. This is happening in the first 10 to the minus 30 some seconds. And during that tiny amount of time, the universe grows from something much smaller than an atom to something as big as galaxies. There are these fluctuations during inflation of the field, so space is ripping apart so fast that it just excites space-time itself. You can't do it without making space-time a little bit crinkly. And those crinkles turn into galaxies and all the nice structure that we see in the universe today. But you have to be a little bit careful, because it turns out that once you get inflation started, it can be really difficult to make it stop. And that's this idea of eternal inflation. And what's going on is you have this medium that's filled with this substance, often called the inflaton, that doesn't dilute as the universe expands. It's got a constant energy everywhere, and so it's causing the universe to undergo accelerated expansion. Once these bubbles form, they grow, but as they grow, they're also getting ripped apart from each other by the expansion of space. And the idea is that somewhere in that mess of bubbles, you'll find a bubble that contains our universe. Let's say we live in one of these bubbles. Just the fact that we're in this turbulent, expanding sea and the bubble is not totally left alone, it's getting buffeted by all these waves, that'll show up as very, very long variations in the CMB. If we run into another pocket, then that would actually show up as a fairly dramatic bruise in the CMB. If I were to look at this light in different directions, then I would see some disk in the sky where the intensity of the light is a little bit different. If you wanted to go out and test this idea, then one way to do that is to go look for these bruises in this light from the early universe.